Today's lesson is about sketching the more difficult questions on third-degree functions. And I like to give you this level 4 type of questions in tests and exams. Now you will need a few colors if you want to do the explanations on your examples. 1, 2, 3, 4, 5. More or less 5 colors. Alright. They will give you a function, let's say fx equals ax to the power of 3 plus bx squared plus cx plus d. And as you can see, this standard form doesn't have any coefficients, anything. The only thing that I can deduct from this is that is a positive cubic function.
So even in the standard form, if the a is positive,
yes, otherwise I would have said minus. Yeah. Okay. But they also give you some properties. And you need to know how to apply these properties as points on your x and y axes so that you can draw the function. Make a sketch graph. They ask for a sketch graph. It means that not everything is on the picture. Only a few properties are there, but picture would look something like this. Okay, that is a sketch graph. Right. Let's look at our first property. It says f of minus 1 is 0. Now, you must remember on Friday we had a lesson where I told you where I showed you how to interpret maths language into English language. Can you remember? It's that table. You have to know that. You have to understand what everything is. What does this mean? F of negative 1 is 0. What is it? Pardon?
It's the x-intercept.
It's the x-intercept. So, the x-intercept is where x is negative 1 and y is 0. So, of this that I write in pink is what you should think. Okay, so now that you have figured out what that means, you put your coordinate on your axis. X is negative 1. It should be there. The next one. The first derivative at negative 1 is 0. What does that mean?
The turning point.
Turning points. Okay, so the turning point. And what is the x value of that turning point? Negative 1. So the turning point's x value is negative 1. What is the y value? No, not 0. We don't know. We can't substitute it in there because we only have the standard function. So we can't actually get the y value. That means the gradient is 0. So the turning point is 0. The gradient is 0 on that point. Okay. So what you do now is you take a pencil. And I know that the turning point is on negative 1, where x is negative 1. So I draw a dotted line there in pencil. And I say this is my turning point. It must turn on this line somewhere. I don't know yet where. Remember, you can't leave this dotted line when you're done with your sketch because that represents a asymptote. So that's why I say draw it in pencil, and when you've drawn your graph, you rub the pencil out. Don't leave it there. Right. The next one. The first derivative is larger than 0. What does this mean? The gradient is positive. Yes. So, the gradient is positive. This is what you think. So I have a positive gradient where x is smaller than -1. So that must be -1. And my graph somewhere will look like that. Below to the left hand side of -1. We have a positive gradient. The next one. The first derivative is larger than 0. What does that mean?
Gradient is not positive.
Another positive gradient. Can I have two positive gradients in a cubic function? Yes, you can. So there's another gradient and it's also positive. So I have another one where x is larger than 2. So this must be 2. And from 2 onwards.
Dames en heren, jammer om te steur. Net almal se stilte kry asseblief. Collega's, die departement gaan in die volgende 10-15 minute hierso wees om 'n head count van die leerders te doen, hulle wil al die leerders kom tel. Ek sal in die volgende paar minute dan so oor 10 minute 'n afkondiging maak dat al die leerders dus dan 4 kant toe gaan. Kry net so lank alles in orde saam met die klaslys en aanwezighede dat dit reg is so 5/1, 10/1 se kant. Dankie.
Okay, let's carry on. You'll have two videos, an A video and a B video. Okay, let's carry on. This one, what does that mean? F of 2 is -6.
That's a point.
Just a point. Okay, so x is 2, y is -6. X is 2, y is -6. So there's my point. Then we have the first derivative at 2 is 0. What does that mean? Another turning point. Can I get 2 turning points? Yes. Right. So there's another turning point, and I have the x value as 2. Do I have a y value? No. Why can't I say 0? Because this represents gradient equals 0. It's not the y value at the turning point. So I know the turning point has an x value of 2. Another dotted line. Turning point must be somewhere on that line. Pardon?
Isn't it at -6?
Yes, it will. Okay. Now we look at our last clue. The first derivative is smaller than 0. What does that mean?
Gradient.
Negative gradient. Well done. Gradient is negative, so I have something like this. Between -1 and 2. Okay. Now you put everything together. It looks like I'm going to turn on this x equals -1, and it looks like I'm going to turn here at 2 -6.
You're going to turn there or the intercept?
We're going to turn there because I have to turn on the green line. So I'm going to turn there. Then I have a negative gradient, and then I'm going to turn here and go up. Okay.
So the rules give us all of the x-intercepts or
They don't always give you. Alright, we don't know what this x-intercept is. So don't mark your x-axis up to the end. You just use what they give you. So I actually shouldn't have dotted the 3. Okay. We don't know where that intercept is. We don't know where this intercept is. But we know that it has to turn on -1 and it has to turn on 2. And we know that this orange dot is part of the graph. We also know what the name of the graph is. Everything is f's. So this must be fx.
I just want to know, how did you know that the turning point is like beyond the x-axis if they didn't give us the y?
Because they didn't give us anything else. They only gave us 2 dots and they say this is a turning point, this is a turning point, so I assume that it should be there.
And then if they said it was equal to like 3 or something, then you know -1.
Yeah.
No, but they gave it to us as a turning point.
Yes, it was at -1. Alright. Now, the last thing that you need to remember is you have to rub this out. Don't forget that. Alright. Our next question, let's hope we can finish this one, is they ask you which x values are used when you say the first derivative times f is smaller or equal to 0. Okay, let's start at the back. What does smaller or equal to 0 mean? Negative. I have to multiply two things and then get a negative answer. What can I multiply to get a negative answer? Negative times positive or positive times negative. Okay, let's do the positive times negative first. That will give me a negative answer. But how do I interpret that? You say, if accent x, what does that represent? Gradient. So where's the gradient positive? What does fx represent? Yes, the picture, the graph. Okay, let's say the graph. Now you have to put it together. Where is the gradient positive? It's here and here. Where on that part do I have a negative f? Under the x-axis. So it's those x's and these x's. Only them. Now you have to write your answer. X is smaller or equal to 0, -1, or, because I have 2 parts, between 2, and they didn't give us the x-intercept there. In this case, you make it an alphabet letter, A, or P, or Q, or whatever. No, it doesn't have, it's not infinite because it stops there. There, only there, the picture is negative. Okay, so we have to stop there. So it's between 2 and A. Between means the x must be in the middle, and it's smaller or equal. So that's my first part. But we have another option. A negative times a positive also gives me a negative. So where is the gradient negative? And where is the picture positive? The gradient is negative here. Where on that part is the picture positive? Nowhere. So this doesn't have an answer. So you can leave this out. So that is your only answer. Yes.
Like if we use A as under x-intercept, we have to indicate it on the graph. So it's
You have to indicate it on the graph or with a picture like this. A small picture.
So if we indicate it on the graph, that means we can actually continue the line.
Okay. Any questions? Everybody happy?
I still don't understand how you use the turning point and the one of the x-intercepts.
Okay, they only give us a few. This one.
And this one, so when the turning point and x-intercept is the same, it bounces.
Yeah. Okay. Let's look at question number 2. You don't have question number 2, but this is an extra example. The first characteristic they give us is if absence of 2 is 0. What does that mean?
Gradient.
No. Gradient is with a backy. Turning point is equal 0, equal 0. Right? So the turning point, x value is 2. Do we know what the y value is? No. So we know that we can draw a line at 2. That is my turning point line.
And does this graph have to be to scale?
No, not at all. The next one, the first derivative at -3 is 0. So we have another turning point. X value is -3. Do we have a y? No. So we can draw at -3, we draw our dotted line. That's our second turning point. We know somewhere on that line we have to turn. The next one is the backy one. So the first derivative is larger than 0. It means positive and gradient. Positive gradient. So we have a positive gradient between -3 and 2. Where f is 0, this means it's the x-intercept. Where f is 0, another x-intercept. So we have -1, 0, -4, 0, -1, -4, f dots. Now the question is, what does my graph look like? We know that between -3 and 2, we have a positive gradient. So it will look like something like this. Do you agree? Okay. So on -3, I have to turn. But I have to go through -4. Okay? And then I have to go through -1 and turn there again. Okay?
Ja, met die onderbreking kan alle leerders nou dadelik na die vierkant toe beweeg. Wanneer julle in die vierkant kom, moet julle asseblief jou samewerking gee en in julle voogklasse alfabeties gaan staan. Ons vra dat die voogpersoneel asseblief sal help en onmiddellik na die vierkant toe beweeg. Dankie.
Yeah, alphabetical order. That's all.